in this example we're trying to find the volume of this pyramid, but the problem with this is the way we know how to do volume so far, we need to know the height of the pyramid. So with this pyramid here, we don't know what its height is. Now I know the volume of a pyramid is equal to 1/3 of its base times its height. I can work out the base of this not too bad, because the base is a square, which is 5 by 5. So I can work out the base here pretty quick with length times width, which is 5 times 5, which is 25 centimetres squared. The problem comes because I don't know the height, and so we need to find this height. Now we know this length of this triangle, so what we can do is we can make a right angle triangle here, and this we can use with Pythagoras to find this side. So I'm going to call that one x for now, which is what we're looking for, but the problem is we need to know this length to be able to use Pythagoras. Now to use Pythagoras, we're going to have to make the full triangle first. I'm going to call this length y, and if I draw the picture, to find this bottom now, we've got 5 on one side and 5 on the other. This is this side and this side, and we're looking for what y is. So to do this, we're going to use Pythagoras' theorem. We're going to call this side A, this side B, hypotenuse C, and do c squared is equal to a squared plus b squared. C squared is equal to 25 plus 25. So c squared is equal to 50. We want just c so we can find the square root. So c would be the square root of 50. And I'm just going to pause that in my calculator and work out what it is. So what I've found out is this side length c is 7.07, but I only need the distance from here to here, which is half this full distance. So I'm going to call, I could call it another letter, but I'm just going to write it in. And when I did 7.07 divided by 2, because it's only half the distance, I found out this side was 3.54. Now, the reason I might have a slightly different number to what you expected is I kept every single decimal point in my calculator to do that number. Best bet to keep working with the number you got instead of rounding it off. It will allow you to be more precise. So I've got 7.07 divided by 2, 3.54 for this. So now if I need the height of x, I've now got a triangle which has got 12 on this hypotenuse. We've just worked out that this is 3.54 down here, and the last distance we're looking for was this side x, which was our height of our triangle at the start. So again, it's Pythagoras' theorem. The hypotenuse this time is there, so c, a, b, and I want to work out a squared, c squared take b squared, so a squared, 12 squared take 3.54 squared, so a squared is equal to 144. Square the number on the calculator I had before, gives me 12.5. So a squared is equal to 131.5. And then if you want to know a, find the square root of that side, make the square disappear, and the square root of that side, 11.47. There's a good thing you can do here to see if you're on the right track. If this side was 12, and if that's the hypotenuse of the triangle, this side should at least, or has to be less than 12, because it has to be shorter than what the hypotenuse was. 11.47 is less than 12, it means I'm on the right track. So now I know the height of this triangle, which I've just worked out, is 11.4, forget about that for a second, 11.47, so we go back to my volume over here. It is a third of the base times the height. We'll just work out the base is 25, so my final volume is a third of 25 times, depends on what I want to today, 11.47, and I'll put that into a calculator. Sorry, this was 12, I don't know why that one didn't work. So 12 times 11.47 35.88. And because we are working with volume, always make sure that you are in centimetres cubed. Excuse a little bit of drawing, I'm just not going to go back and restart it all because the pen didn't quite do what I wanted it to